Are your brains actually ready?
No.
Yep.
If I had the integral of sine squared x cos x, do we know how to do it? So the sine becomes a cubed divided by 3. The cos x is still there. Can you imagine how many people watching this don't understand what I'm doing? Especially one as another method. So you can make that a cube divided by 3. You've got the cos x, what do I say? For the ride.
Along for the ride.
Yeah, along for the ride, that just stays there the whole time. But then you've got to remember to divide by the derivative of the inside, which is derivative of the sine.
Cos.
Look at your face. Cos x. And we put plus c in the question stuff. So that was easy. And the only reason it works is because that function of x and that function of x cancel out. And if you wanted to, you could go through and check that we're right. How do we check that we're right?
I have a question.
Yes.
Why?
So that's your mucking up your brain why it worked. If I wrote that as the integral of sine x squared, will I go square brackets or curly brackets? Probably that one, cos x. And that's a reverse of the chain rule. So the only reason we could do that in that shortcut method, that observation method, is if you know it's a reverse of the chain rule. And you know how many people don't realise that that just means bracket squared. So that's in principle like doing something like this, 3x plus 1, this might help you, to the squared to the 10 times by, well I'm going to write it there for a moment, 6x dx. So is that the reverse of the chain rule? How do you know? The outside is a derivative of the inside. I said a derivative. The derivative, a factor and multiple of the derivative of the inside. So that's the same as that. So that's just one of those, which is the reverse of the chain rule. So we've got a problem. We need to turn the sine squared into sine squared x into not a squared. Come back over here. Because of 2x's, you know these, you should know all of those already. That's not what this video is about. If I rearrange that and made it as sine as the subject, we're turning a sine that's squared into a cos that's not squared. But the x is going from an x to a 2x. So Alex's question a moment about cos, I could put times cos on cos, but that's just going to make it more complicated. So let's change it into that. Sine squared can be 1 minus cos 2x on 2 dx. Now can you do the question? Yeah. So what would a lot of people do? They put the half on the outside, which, I'm okay about that. I can do it with the half on the inside. So what's the integral? Okay, Gracie. What's the integral of 1 minus x? Where's the cos 2x come from? It's actually a minus cos 2x. Cos comes from?
Cos. Yeah.
Divided by?
2
Plus
c.
c. So our answer is just x on 2 minus sine 2x on 4 plus 8 constant. If I call that constant 1, I could call that constant 2. Questions? Now, some of that won't sink in until we do the next question. I'm going to have to move this over this way a bit. How can I turn a cos into a cos squared into a not squared? By using cos 2x, manipulating it into that form. So wherever I've got cos 2x, I can write that. So instead of cos 2x, now can you imagine what I can do with this if I put extra numbers here? Or if I make it like 2x plus 1 in the middle? Yeah, this makes it more complicated.
Cool.
So I can just change that into 1 plus cos 2x on 2. Take to think about there for a second. So I can take the half outside. You okay with the half outside? Good. Why? Better get rid of fractions. So what do we do? X, 1 comes from? X. Where's cos come from?
Negative sine?
No, sine will give us cos positive.
Oh,
sine
yeah,
give-
right.
So, on 2 plus c, question's done. So we've got a half x, or x on 2, I wrote last time. Sine 2x on 4. And you know what we're going to do next? We're going to make it into more complicated ones. So, now we've got a problem. I don't have a sine x, I've got a So Alex, you know what's this bit, mate? I think you're okay with this. I want to turn that x into a 2x. So I rewrite that as a 2x. What do I have over here now?
Which is a 4x, because you're treating the x as you're treating 2x as x, so you just times it by 2.
Yeah, got it. So you could fill around and do lots of things. All I think of is if I make that a 2x, that becomes 8. Of course, I could give you a 6x and you make that a 12x and you go on and on and on. So how do I rewrite sine? Using that. 1 minus cos 4x, putting all the steps in on 2 the x, take the half outside again. 1 minus cos 4x. So it doesn't really make the question any harder. So what do we got? So we got the integral of 1 is a half x. I saw the half and said half. And where's cos come from? I didn't even mention the sign, the minuses comes from. Sine. I could have said, where does the minus come from? The minus cos, the minus sine. I'm just going to say the cos came from the sine. And what do we have to remember to do?
Plus c.
And also,
The inside.
yeah, divide by the inside, the derivative of the inside, which I often do that for. Yeah, answer done. So on the next video, I need to then make it much, not much, a little bit yuckier. And that's integral that. If you want to check it, you can muck around and check it and see if it goes back to what we started with.